Good afternoon. I am Dr. Arunkumar, Professor and Head, Department of Mechanical Engineering, Satyabama Institute of Science and Technology, Chennai. Today, I am going to deliver a lecture on shop floor control, factory data collection, and master production schedule, MPS. First of all, I would like to start with shop floor control. Shop floor control system can be defined as a system for utilizing data from the data processing file. So we can maintain and communicate the information on shop orders and work centers. So it is also known as production activity control. If you consider any manufacturing industry, the shop floor control is very essential, not only for utilizing data from the data processing file, but the professionals, they have to maintain and communicate information on present job order and then the work centers which are available in the particular concern or industry. So that is why it is called as production activity control. Next, I can move on to the function of shop floor control. There are 5 functions important in shop floor control. The first one is scheduling, that is product scheduling, when the product to be manufactured and when the product to be dispatched, that is dispatching. And then the follow-up after dispatching, the follow-up function is very essential in order to get the customer satisfaction. So once the customer is satisfied, then only they can give repeated order for any kind of components. So follow-up function is very crucial with respect to the customers. And then the providing output data. Output data not only related to the product, but also about how many products per day it can manufacture in that particular unit. And then what is the capabilities of the factory in order to manufacture that particular product or part. Then providing efficiency. So when you consider the functions, apart from scheduling and proper dispatching, the follow-up with the customers will be crucial. Based on that, the customer satisfactions can be arrived and one can get the repeated job orders for the any particular part. So providing output data, it is also follow-up communication, which is very essential for any particular industry. And then providing efficiency, not only in dispatching the component in a proper manner, but also proper follow-up. And then the quality of the products manufactured by the concern should be meet with the customer's requirement. Also, it should be as per the standards. So I would like to give an illustration of shop floor control. In order to understand the concept of shop floor control in a very simple manner, I would like to consider this illustration. So now you can consider the new order X, Y, and Z, which is coming from 3 different customers. So now this is the particular place where unreleased orders will be kept. That means the orders may not be approved for production. And then this is nothing but the production control people or professionals who can operate or control the unreleased orders. So once some new order X is got approved from the authorities, the production control people, by considering the availability of work centers, availability of the machine tools, as well as the skilled professionals, they will release the orders. So it can come as an input. So this is nothing but work in progress. So work in progress, so the professionals or skilled laborers, so with the help of the machineries and the available machine tool, they can manufacture or they can do the machining process of the particular product. That means they can convert the raw material into a full-fledged product as per the customer requirement. So we have to consider the capacity of the plant. That is very essential one. The capacity in which it can manufacture a particular part or product. So it can be regulated with the help of production control team. So the output is nothing but completed orders. So I would like to give a gist about this shop floor control with these small illustrations. So here, normally the unreleased orders are kept. That means new order X and new order Y and new order Z coming from three different customers. The production control people, by considering the available manpower, the available machineries, tools, as well as the materials, and then they will consider, more importantly, the capacity of the plant in which it can manufacture a particular part or component per day or per shift. So based on that, they will regulate the production control people, they will regulate, and then the output is nothing but completed parts. The completed orders will be dispatched to the particular customer within the stipulated time period. So the success of the manufacturing company fully depends on how it can process and how it can dispatch as per the schedule, and how they can follow with the customers. So now, if you see that in this particular illustration, it is nothing but the manufacturing lead time. The manufacturing lead time, the time difference between job order receivable from the customer and delivery of the product. Here, the delivery of the product in terms of output to the specific customers are mentioned. So here, the production control people, they have to regulate the input as well as they have to consider the capacity of the plant, and then the outcome should be a quality one so that they can receive the new orders quite often. Otherwise, the customer, dejected customers, they will think over the competitors. So here, the significant process is the production control people, they have to control the input and they have to consider the capacity, and then they have to manufacture the product as per the customer specifications, and they have to dispatch as per the schedule. I hope you might have understood this particular illustration with respect to the shop floor control. So now I can move on to phases of shop floor control. The first and foremost phase is order release. This phase provides the documentation needed to process a production order through a factory. Normally, a documentation, a proper approved documentation is required for processing a production order. As I said in my previous illustration, the customer X, customer Y, and customer Z might have given different job orders. But in order to process the job order or production order, specific approval from the production planning control team is very, very significant and essential one. Once the document is available, then only the production planning and control people, they will process the production order through a factory or through a company. So the collection of document, this kind of document is called as shop packet. So the shop packet, which consists of root sheets. Root sheet is nothing but the sheet which consists of sequence of manufacturing or sequence of production operations with available machine tools and then the necessary instructions. So all manufacturing concerns, they might have got root sheets. So based on the root sheets only, they will proceed the machining operations in a very sequential manner so that the job can be completed within the stipulated time period and without affecting the requirement of the customer. The most important thing is material requisitions. So the material is the first and foremost important part. Without material availability, we cannot proceed for a manufacturing of any component or any part or any product. So material requisitions are very, very essential. The production planning and control people, they will consider the availability of the material, okay, the inventory of the material, and then the job order. According to the job order, they will check whether the material availability or material inventory safety stock is there then only they can proceed. The third one is job orders. The job order is nothing but the the work to be carried out in a particular concern and in a particular work center. So it specifies that particular job codes specifies the nature of machining process to be carried out in a particular part or component. Then I can move on to move tickets. It is nothing but that move tickets are nothing but it can specify the workflow process in the work centers. So part list, you know about if a particular product is available, the part list is very, very essential. I would like to give a real-time example. So if you consider Boeing 707, so it might have consist of 2,565 sub-assemblies. So each and every sub-assembly might have consider of minimum 4 components. So almost aircraft consists of more than 10,000 parts. So if you want to go for aircraft manufacturing and all, let us consider a Boeing company environment. They have to prepare a part list of 10,000 components, but they can access the accessory plants or accessory companies in order to manufacture the different parts within the stipulated time period. So order release is very, very essential because once the production has been performed, then only the product will be ready. The product as per the requirement will be checked by the quality control and quality assurance department, and then it will be dispatched to the specific customer, and then the follow-up should continue in order to know the customer satisfaction. So customer satisfaction is the key for success for any manufacturing process. So in this case, now you have to consider the root sheet. The root sheet, it not only consists of the sequence of individual operations, but also it contains the machining process sequence as well as the machine tools required for performing the machining operations with some necessary instructions. You all know about material requisition pertaining to a particular product. It may differ from one product to another product, or it may differ from one part to another part. Next one is job code. So it defines or it specifies the work to be carried out on a particular part or on a particular component. Move tickets is very, very essential one because the workflow from one particular machine cell to another particular work centers or one particular work centers to another particular work center. The next part list, it is nothing but the list of part should be manufactured in order to get a complete and full-fledged product within the stipulated time period. Next, I can move on to another phase. The second phase of shop floor control. It is nothing but order scheduling. Order scheduling execute the dispatch scheduling. So dispatch scheduling is nothing but so when the product to be manufactured, how many product to be manufactured. So these are all the things so should be planned by production planning and control department. Accordingly, the dispatch schedule will be prepared. Let us consider an automotive industry. I would like to explain the order schedule with respect to an automotive industry. They are manufacturing different automotive components. Let us consider the brakes and then axle and knuckle, steering knuckle, as well as cylinder caliper, etc. So suppose if an automotive manufacturing company urgently requires front axle and rear axle, normally they will inform to the particular manufacturing firm or concern so about the requirement. So immediately it will be communicated by the authorities to the production planning and control department of the particular concern, and the production PPC team, they will plan for dispatching the front and rear axle of an automotive company in the priority basis. Now, then the second priority may be the brakes. So in that case, the brakes is a part that can be manufactured in that particular concern as a second priority. Like that, the priorities have been defined by the PPC engineers and PPC professionals. Based on that only, they will prepare the dispatch schedule. Now, I would like to specify about two different elements of order scheduling. The first element is machine loading. The second element is job sequencing. So, the different kind of machines are available in an industry. Let us consider SPM and GPM machines. So, SPM is nothing but special purpose machines. So, GPM is nothing but general purpose machines. So, special purpose machines normally available if the job order is very high. If a particular customer is providing the job continuously for the same concern, means they will install a special purpose machine. So the special purpose machines are arranged based on the sequence of machining operations. The advantage of a special purpose machine is the machine loading can be the time taken for machine loading, time taken for work holding, time taken for tool fixing of the tool will be very less. Suppose when you consider general purpose machines, it can be arranged in a particular order. So depends upon the component to be manufactured or depends upon the part to be manufactured. You have to consider the sequence of machining operation with respect to the root sheet, and then we have to move the particular raw material from one particular machinery to another particular machinery. So the time will be taken for fixing the component and removing the unfinished component and fixing the component in the second machine and removing the component from second to third, fixing the tool in the tool holding device and removing the tool from the tool holding device. So it will take lot of time, and time taken for delivery will increase. So within the stipulated time period, so we cannot able to give the dispatch schedule for a particular component to the customers. That is why if job order is continuous and job order is enough for a specific period, normally they will prefer SPM machines. So how the two elements of order scheduling will play a crucial role. So machine loading and job sequencing. I can move on to priority sequencing rules or dispatching rules. So normally the production planning control engineers or professionals, they are considering these kind of priority sequencing rules or it can be dispatching rules. So you have to understand these terminologies. One is SOT. SOT means shortest operating time, and EDD, another term which is very significant, earliest due date. STR. Now, STR can be calculated with the help of a small formulae. So, STR is nothing but slack time remaining. So, now you have to consider a due date. For example, an automotive product like brake, it has to be manufactured in a brake manufacturing firm. So, the due date given by the manufacturing firm is 30th April. So, now today is 23rd April. So 7 days, 7 into 24 hours are the time available before the due date minus remaining process time. So normally if you want to manufacture the brake, the raw materials should be undergone various machining operations. For example, while calculating the STR, if 2 or 3 manufacturing processes are completed, remaining 2 manufacturing processes are pending, means you have to consider the time taken for finishing those 2 manufacturing process, and then you have to subtract with time remaining before due date. That means 7 into 24 hours minus the remaining process time may be 10 hours. So that is slack time remaining. So now you may be in a position to understand how to calculate STR by the PPC professionals. Now, another terminology which is very significant one as far as production control is concerned. One is STR divided by OP. It means that slack time remaining divided by number of remaining operations. And the two more definitions which are very crucial as far as for calculating the critical ratio CR and Q ratio QR. Critical ratio. Critical ratio is nothing but due date minus current date divided by number of remaining working days. Let us consider another example in order to understand the critical ratio in a very systematic manner. So now a manufacturing, an automotive component manufacturing firm. Let us consider they are manufacturing the front axle. So the due date given by the manufacturing firm to the customer is 30th April. Current date is 23rd April. So now the time difference is 7 days. Let us consider that particular auto components manufacturing industry are running 3 shifts. So 7 into 24 hours. So that is the time period available divided by number of working days. Let us consider in between 7 days. So 5 days are working means 5 into 24. So 7 into 24 divided by 5 into 24, that will give critical ratio. So in another case, let us consider a cylinder caliper which is manufactured in an automotive or auto component industry. The due date is 30th April and the current date is today. So 23rd April. 23rd April. So in this case, we can get 7 days. So 7 into 24 hours. So if you consider in terms of days, 7 days. Suppose if the company is manufacturing the auto component without giving any leave or off for the particular employees. So 7 working days. 7 divided by 7. So in that case, the critical ratio CR will come as 1. So now we can move on to Q ratio. How to calculate Q ratio as far as priority sequencing is concerned or dispatching is concerned. So now you have to consider the slack time remaining in the schedule. We have already calculated the slack time remaining. That is nothing but time remaining before due date minus time remaining process time. In this case, the cylinder caliper. Let us consider the third industrial example. Cylinder caliper is one of the automotive component. So in this case, the time remaining before due date is 7 days. So 7 into 24 hours divided by Q time. Because before taking that particular product, there might be some products to be manufactured based on the dispatch schedule. That is why it is very essential to consider Q time by the manufacturing firm. So the rule specifies that first come, first served basis, last come and last served basis. It means that if a customer X needs to manufacture a particular automotive component, if they place the order first, then the manufacturing firm, auto components manufacturing firm, they will serve and they will produce the part and they will supply to the particular company in the time, first priority. And if the particular concern or concern X or concern Y, they are giving the job order to a automotive component manufacturing company as a last means, so that manufacturing firm also, they will serve as a last. So that's why it comes as last come and last serve, first come and first serve. I hope you might have understand the priority sequencing rules, which are very, very essential for planning the dispatch schedule. Now I can move on to order progress. Order progress phase is very, very crucial for a production firm, because in this particular phase, they will consider the status of various orders existing in that particular plant. A manufacturing plant, even if you consider an automotive components manufacturing plant, they might have manufacturing 20 to 25 different components. So they will consider the existing work status existing status of the order. So let us consider an example in order to understand in a very systematic and clear manner. So they are manufacturing brakes, calipers, axle, and then cylinder. So now the priority goes to brakes means, so they will consider what is the existing order for brake and what is the facility and material available for the brake. So that's why they will take the status of various orders which is available in the existing plant. And then they will consider work in progress. What is the current um, production work is going on, work in progress. Apart from that, they will consider other characteristics that indicate the progress and performance of the production. So there are three forms of order progress report. The first one is work order status report. That means what are the existing work order available from customer X, customer Y, and customer Z. And they will check what is the progress made by the firm with respect to production of the particular component. An exception report which specifies some of the components may not be given priority because of the demand raised by the particular customer. That's why they can give some exception, that they can give some time period, they have time period, so that they will, in the priority wise, it can goes beyond certain level. So now I have represented a picture. It shows very clearly about the future of shop floor control. So up to this, you might have come across various phases, three different phases of shop floor control in the existing production firm, even in the existing automated firm. But now, with the help of artificial intelligence, virtual reality, the future of shop floor control will be like this. By standing in a single place, even two professionals, they can able to control a big manufacturing firm from a single place. So now most of the automated industries, they are using programming logic controller in order to control the shop floor. Okay, so PLC based control of machineries as well as equipments. And then now the future of shop floor control will be influenced by virtual reality as well as virtual keyboards, and then apart from that, artificial intelligence and cloud computing. Now I can move on to factory data collection systems. So it is very essential to collect different data pertaining to a factory or shop floor, and then normally they will use manual methods in order to gather the informations, but as of now they are using some automated systems in order to gather the data. So when they are using any manufacturing firm, when they are using automated systems, it doesn't require any human interventions or human participations. Normally, in order to collect the data pertaining to a product or pertaining to a machine tool availability, and then material inventory stock, as well as the maintenance, preventive and breakdown maintenance activities. So normally they will use the manpower, that is production planning people. So nowadays, fully automated systems, fully automated industry doesn't require any human interventions. So even though they are using the automated systems, so what kind of data is collected by factory data collection? The first and foremost one is the list. We have to take the list of number of parts that are scrapped. That means how many parts it doesn't have any usage at all. The list number of parts require rework. So you have to consider some of the parts can be reworked with the help of the sophisticated and latest machineries available, or they can use special purpose machines in order to bring back to the record level. That's why they should consider the list number of parts record rework. And then the third one is equipment downtime. For example, in a particular manufacturing firm, if there are 4 or 5 machineries are available, in which one particular machinery is breakdown. So that's why the production planning people normally they will give job schedule for maintenance people. The maintenance people they have to rectify the problem and immediately they have to hand over to the production people. Then only the production will resume. It won't affect the productivity. So the time difference between the job maintenance job order receival and the delivery of the particular machine, that means hand over the machine for the production, will be calculated as downtime. So because downtime is very, very essential, so we have to reduce the downtime in order to increase the productivity. So time clock by employees, it is a human resource department. They will take care of the this particular activity. Time clock by employees for punch in and punch out. So this particular biometric system can be used to calculate how many hours the particular employee X or Y is working inside the industry. So time taken at each work center, it is pertaining to PPC engineers because normally they will calculate the time taken at each work center in order to manufacture a full-fledged product within the stipulated time period. Normally, a machining center or a manufacturing firm which consists of a machining center. So it might consist of so many work centers. So the job should undergo various process in each and every work center. So time taken at each and every work center can be calculated by the PPC people. Labor time in each work order. Labor time means the time taken by the operator or labor in order to finish the particular machining operations. So next I can move on to types of data collection systems. So there are two types of data collection systems are available. One is online data collection system. Another one is offline data collection system. So you can easily understand even by seeing this particular type itself. So online data collection system which requires the computer, full-fledged computer system or computer server so that the data pertaining to various shop floor activities are entered directly in the computer system. So this database is very, very essential in order to plan, monitor, and communicate different data pertaining to the shop floor, to the work center, as well as to the working professionals. The next one is offline data collection system. So the data are collected temporarily by employing some manpower or even a system, so automated system. But it will not be directly stored in a server, computer server or not. It can be stored in the temporary or secondary storage device, and then from the secondary storage device, the data pertaining to the shop floor activities so will be processed by the plant computer in a batch mode. Okay. Now I hope you can able to differentiate between online collection system and offline collection system. If I want to define in a very systematic and very refined manner, so online data collection system is direct data entry into a computer system and storage of data pertaining to shop floor activities in the server or device. Here, it can be collected by temporarily and stored in the storage device, and then it can be processed in a batch manner at the later stage. So now move on to automatic identification method. So it refers to various technologies used in automatic or semi-automatic acquisition of product data. So normally the acquisition of product data is very, very essential because if a manufacturing firm is manufacturing 20 different components, so a production planning engineer can't able to remember all the data, major dimension or minor dimension or sequence of operations or the materials record or manufacturing sequence, inventory plan, everything cannot be remembered by a PPC professionals. That's why they will keep the data acquisition system, and then data acquisition and data storage is very, very essential in order to progress in a very systematic manner. So it consists of automatic identification method is consist of three basic components. One is encoded data, encoding with the help of encoding concept. The second one is machine reader. It is nothing but a scanner. And then the third one is decoder. Now I can move on to types of automated identification technologies. There are 5 identification technologies are available. This is very, very essential for a mechanical engineer, especially manufacturing engineers. To nowadays, in most of the automated industries, they are using automated identification technology. One is barcode, another one is RFID, radio frequency identification system. The third one is magnetic stripe. The fourth one is optical character recognition. The fifth one is machine vision. So barcode, you might have seen in various places, in various products. RFID, I would like to explain in the next stage. Magnetic strip, you might have seen even in ATM cards, the magnetic strips stores the data in an efficient manner so that when you swipe, then the data will be read by the system. Optical character recognition, also advanced identification technology. Nowadays, most of the manufacturing industries, they are using this one in order to identify the data. And then machine vision. So now, before proceeding to each and everything, you should know what are the application of factory data control. One is material handling, another one is manufacturing, another one is the retail sales and inventory, etc. So I would like to discuss one by one. Material handling, which consists of shipping of components, receiving the raw material from various sources, and storage in the warehouse. Shortation depends upon the raw material. For each and every part, they cannot use the same material. Raw material will be different, and the accessory parts, it might have used different raw material. That's why shortation of raw material, shortation of parts are very, very essential. Order picking. So picking the order from the customer X or customer Y or customer Z, and then the PPC engineers, they will control the flow by considering the capacity of the plant as well as by considering the workforce and the availability of the machine tools and material. Of course, material. Parts for assembly. Suppose if a component consists of 5 parts, so all the 5 parts should be manufactured in a particular firm, or else it has to be manufactured from different firm, collected in a single place in order to assemble to get the full-fledged product, in which factory data collection will play a crucial role. As far as manufacturing or production is concerned, it is used for order processing, processing the order, when the product to be manufactured, how many product to be manufactured, etc. So work in process. So what is the work progressing in the manufacturing plant pertaining to a particular product? Machine utilization and worker attendance. This is mainly, worker attendance is mainly concerned with HR department, but machine utilization is related to PPC department. So how many hours per day the particular work center or particular special purpose machine or general purpose machines are utilized in order to make the component. So retail sales and inventory. Inventory is nothing but safety stock. So every company, they have to maintain the safety stock. For example, if a aircraft manufacturing company, Boeing, so they are manufacturing different aircraft components. So based on the demand, they have to manufacture based on the customer order, and based on the demand, they have to manufacture the parts. Apart from that, they will calculate the safe inventory so that they can manufacture the part before due date, and then they will keep it as a safe inventory. Depends upon the huge demand. When demand is huge, immediately they will release the parts from the inventory stock. Warehousing is nothing but a place where we can keep the finished product or finished goods in order to distribute to the various centers. So warehouse is nothing but a storage place. From warehouse only, the finished goods or finished products will be transported to the agencies. Mail and parcel handling, it is pertaining to cargo. Patient identification in hospital. The FDC normally used for patient identification in hospitals, check processing in banks. These are general applications. Barcode technology, it was invented by Woodland and Bernard Silver of USA in the year 1949. It is the most famous technology. Even they are using for, even most of the retailers, they are using this barcode technology in order to identify the product available in the retail shop. So barcode technology also used in shop floor, especially the manufacturing firm, in order to identify the components or parts. Barcode technology. Now, commonly used barcodes are code 39 and interleave 2 of 5, universal product code and code 128. If you see this illustration, you can able to identify the barcode system. So with the help of a reader, it can read and then it will identify the data as well as it will identify the location. Next, I can move on to radio frequency identification. So now RFID tag, most of them even either barcode or RFID they are using. So RFID tag, when you show the RFID tag to a sensor, it will sense and it will send the signals through the antenna to the reader. The reader or transceiver receives the signal and then the data will be stored in the host computer. So if it matches, so let us consider one practical example. In order to open the lock of an industry passage, for example, industry meeting room is there where design people are doing concurrent engineering process, joining all the professionals in order to discuss. So entry is restricted. So normally the permitted people will have RFID based ID card so that they can able to access the meeting hall. So now I can further explain in a very systematic manner. When you show a RFID tag to a sensor or a reader, it will read the data and then the data will be sent to the controller. The controller is connected with a system or server with the help of Wi-Fi, and then from the controller, the stored data will be processed in the computer. So from application side, you can retrieve the data from the computer database so that you can able to identify and know the date and entry time, date and exit time, the locomotive number, lane number. All this data pertaining to a product, pertaining to the employee, pertaining to the sequence of products to be manufactured for customer X, customer Y, and customer Z can be identified with the help of RFID system. That is why, compare with barcode used by the retailers, RFID is mostly used in manufacturing industries. Next, I can move on to automated data collection system. So it can be classified into 3 different types. One is data acquisition system, data collection system, multi-level scanning. We have already discussed about data acquisition system. So by collecting the data automatically or manually, data collection very essential for shop floor control. It can be stored in the database and then recorded in the form of a file, multi-level scanning. So now you can see an overall view of a shop floor control platform. If you look into this particular representation, you can have a very good idea about how the shop floor control platform works on it. Here, the design and planning engineers, they will plan, and then the production people, they are planning the operation sequence. The maintenance people, they are planning the breakdown maintenance and they are planning the preventive maintenance schedule. And then here, manufacturing operations, discrete manufacturing, food and beverage, mining and metals, oil and gas, etc. This is pertaining to a particular kind of industry. So manufacturing operations may differ from one particular concern to another particular concern. So here, the particular manufacturing firm is pertaining to oil and gas and food and beverage, and that's why they have mentioned about it. If an automotive industry, little bit there may be variation, but in order to get an overall view about a shop floor control platform, this particular representation will be very essential and helpful. See that enterprise resource planning, the professionals which are employed for ERP and plant and site planning, these construction professionals will plan the facility management, so line and department, so machineries. These are the workforce, or these are the skilled people, professionals. They are manufacturing the product within the stipulated time period. And infrastructure operations, it is very essential that they will take care of facility management, power generation and transmission, and then transportation, for not only for employees, transportation to finished goods from the warehouse to the various agencies, water and wastewater recycling, etc. These are all the activities will be taken care by infrastructure operations. So normally in a particular manufacturing industry, either it is an automotive industry, automated industry, or it is a manual industry, the different operations in the platform should be in the same manner. Only thing is, if you consider, when you consider an automated industry, the number of employees working in the particular industry may be less. Now, the same shop floor control with respect to two-side perspective. Okay, so the same plant management and scheduling, process supervision, direct control, and then the process at shop floor. So this is one side and this is another side. So two-side perspective. So in this particular sequence, so the process at the shop floor, the various machining process will be carried out in the shop floor, and then it will be checked and controlled by the control people. Suppose many machineries are controlled with the help of a microcontroller or PLC nowadays. So process supervisions, whether the process for manufacturing a particular product or components is carried out as per the route sheet, they will they will do the supervising. So production supervision, whether as per the production plan, whether the component is undergoing the machining operation, so they will take care. Plant management and scheduling. So when the product to be released, how many products to be manufactured, how many hours to be worked. So everything scheduled by these people. So it is a two-side perspective of shop floor control. Next, I can move on to master production schedule. Each and every manufacturing engineer should be in a position to understand the master production schedule, because according to the master production schedule only, one can plan, a company or firm plan the product qualities and planning periods. That's why it states that what company plans to produce in terms of products, qualities, and planning periods. The MPS, it is applicable for all manufacturing industry. Okay, so the purpose of MPS, what is the need for master production schedule? Why it is required for a manufacturing industry? A schedule for production orders. When you consider a manufacturing firm or manufacturing 10 different parts, means production orders. Based on the production order, a schedule should be prepared. Which one is come first and which one comes second, priority. So production orders which give priority for the manufacturing firm. So drives the material resource planning calculation. MRP stands for material resource planning. So raw material is very essential and first and foremost important for producing any component. It may be automotive, or it may be aerospace, or it may be engineering component. But that's why they will do MRP, material resource planning calculations. So input to rough cut capacity planning by PPC engineers. So basis for making delivery promises to customers. So now when a customer is giving a job order to a manufacturing firm X, so now normally they will expect what is the expected date of delivery. So EDD, expected date of delivery, should be given by the manufacturing firm to the customers based on, that is nothing but delivery promise. If you see this particular flow chart, you can able to understand the production planning and control system in a very systematic manner. The first one is sales and operation planning. It is very significant one as far as any manufacturing industry is concerned. Normally, they will establish overall production workforce and inventory levels. Inventory means safety stock of raw material, safety stock of finished goods, and overall estimation of workforce, how many employees or how many skilled laborers are required in order to finish that particular product in 3 shifts within the stipulated time period so that they can satisfy the EDD, expected date of delivery. And then master production scheduling, this is how we are considering. It determines when specific products will be made. Is it today or is it next week? When specific customer orders will be filled and what products inventory are available. So some products should be manufactured more than the customer requirement, and it will be saved as an inventory. When demand increases, the finished parts will be taken from inventory and then it will be released for the process. And then material requirements planning. It calculates the timing and quantities of material orders needed to support the master schedule. So by considering these inputs in a very sequential manner, top order, purchase control and production control process are carried out. This is the flow chart. Will give you an overall view about production planning and control. Now I would like to give a real-time example for master production scheduling. This kind of scheduling normally happens in any kind of manufacturing industry. Let us consider stool X and stool Y are two different products manufactured in a firm. Stool X schedule is stool X is a type of a stool. So it should be manufactured 50 numbers in second week, 50 numbers in fourth week, 50 numbers in fifth week, and 50 numbers in seventh week. So it is based on the job order and it is based on demand. And stool Y is different type of stool. It has to be manufactured 150 numbers in week 1, 150 numbers in week 3, and 150 numbers in week 5 and 6. Like that, a master production schedule should be planned for each and every component or two different components in a systematic manner. That will give you a clear idea for a production control people so that they can manufacture stool X and stool Y within the stipulated time period. And there will not be no barrier for receiving the job order and delivering the product as well as customer satisfaction. Master production schedule should take into account because of customer requirements, customer job order, capacity of the plant, time constraints. What is the actual time available in between the job order receival and delivery? Production efficiency factor. It mainly depends upon production batch size and inventory holding level. Now, the function of master production scheduler is very essential. He has to balance both resources in the form of materials, resources in the form of capacity of the plant, capacity of the machinery, and then requirements. Sometimes customer orders may be very high. So they have to increase the working time. They have to give OT, overtime for the employees so that they can able to manufacture the particular product within the stipulated time period. Safety stock, orders from the final warehouse. So these are all coming under requirements. So the role of master production scheduler plays a very crucial role. He has to balance the resources and capacity of the plant, resources not only material, the skilled laborer, etc. And requirements from the customer side, requirements from the forecast. So he has to balance accordingly the master production scheduler. He has to prepare the master production schedule so that the production process should be carried out within the stipulated time period, and then the manufacturing firm can able to dispatch schedule in a proper manner. So this is an identification, so which is used in master production scheduling in production environment. So this identification for make to stock, and this is for assembly to order, and this is for make to order. So by reading this particular identification, accordingly the production scheduling and production environment, they can prepare the part and they can prepare for inventory or they can prepare for assembly. Now I would like to go for the material requirement planning in order to cover full-fledged manner. So in which product structure file, which gives the structure of various machining operations undergone by the raw material in order to make a particular product. Master production schedule, which gives the sequence of operations. Inventory master file also, these are all input for material requirement planning. So according to this only material MRP should be planned. Okay, these are all will give input for MRP. And then based on that, the outcome will be manufacturing orders, purchase orders, and various reports. So according to that input, MRP should be planned, and material requirements planning is carried out normally in a manufacturing industry, even in automated industry. Material requirements planning is very, very essential. If the planning fails, the unnecessary storage of material not only will takes place in a particular manufacturing firm, but also lead to over cost for the production. That's why the role of material requirements planning is very, very essential for the success of a manufacturing firm. By considering manufacturing order, purchase order, various reports, as well as production planning, then they will plan for material requirements planning. So normally a manufacturing person while working in automotive industry or automated industry, even though they are employing like programming logic controller or artificial intelligence based PLC systems, so they have to prepare the material requirements planning, because material is the first and foremost important